Hello everyone and welcome back to part 2 of this tutorial. Thanks for everyone who followed through on the first one. Once again, before we start, if you want to get the code or if you want to see more videos like this one, please remember to comment down below in the comment section. Also remember to like this video, subscribe, press the bell icon, and of course share this with others. All right, before we start, just a few more things to remember. So first things first, please remember to go to web3coders.com and enter your email address and subscribe. Also feel free to join other communities that we're part of. So join us on Twitter to follow up on our discussions. Join us on LinkedIn as well. We have a LinkedIn account. And of course, join our Discord group. It's open, our Discord server. It's open to anyone to join, where we focus primarily and actually mainly or just only on technical aspects of crypto and blockchain technology. And of course, our YouTube channel. Remember to subscribe, like, and share the videos with others. Okay, so now moving on to today's tutorial. So where did we stop last time? We had this contract, the cold chain contract, which looks like this. And let me see if I can just expand this a bit more. Okay, it looked like this. We had our crypto suite library, as well as the cold chain smart contract. So there are just a few things that we would need to change in there. So in our recover signer function, all we need to do is right after we call the split signature, we need to create a prefix variable. So to be of type bytes and to be in memory. So let's call this prefix. And we're going to just basically assign this with the following string. So it's going to be \x 19 Ethereum signed message. And you use a colon and then backslash n for a new line and 32. So essentially what this is saying is we're going to put this at the beginning of the message that we're about to verify. So the whole idea behind this is to make sure that when people sign, they don't get tricked into signing transactions. So you add this in front so that it's clear that it's time the transaction is being signed. Now we're going to say bytes 32 prefixed hash. It's going to be kekak. So we're going to call the function we used previously. If you remember, we had that being used somewhere. Yeah, so we had that being used somewhere. So it's a hashing function inbuilt, and we're just going to say ABI, just like we did before, dot encode packed, and we're going to pass in the prefix as well as the message. Okay, so now what you get is our message will be added right after this. So what is 32? 32 here represents the size of the message. So this is the message length. This message would be of size 32. You see bytes 32, we have 32 here. So now instead of message down here, we need to take the prefix hash and put that in here. Okay, so if we try to compile our contract again, okay, we can compile and just some warnings. Okay, so now that we have our contract, how do we actually use this? You know, how do we test that it works? Okay, so we're going to have to leave the browser and use an IDE. I'm using VS Code. You can just go online and go to VS Code. Just search for VS Code and download that. Right, so this is a code editor. It's free and open source for you to use, available on major operating systems. So after you install that, also make sure you have Node.js installed. So you're going to need the LTS. You don't necessarily need the latest features, just long-term support. Find the one that works best for you, install that, and then ensure that you have NPM. So NPM is the package management library for Node.js. So on NPM, we'll be able to access all sort of different libraries, like the popular web3.js, which is essentially a client-side library that allows you to connect your JavaScript or TypeScript applications to the Ethereum blockchain and interact with the virtual machine with smart contracts, perform transactions, sign messages, and all sort of other utilities. Okay, then once you have that installed, we're going to be using something called Truffle, the Truffle framework. So let's search Truffle framework. So this is just a set of tools for smart contract development. It's been around now since I think 2017 or so, or 16. I first used it in 2017, and they keep improving, which is really commendable. So what we're going to do is we're going to, so you first of all have to run. So let me get the exact command. So you have to install Truffle globally. So if you go to tutorial, so you have to run this command first of all, right? So you go to trufflesuite.com/tutorial. You run npm install -g truffle. What that does is that it installs the Truffle CLI globally. So on your machine, when you type Truffle version, you would see, you get back this information. Okay. Then we're also going to use something called Ganache. So of course, as you know, in order to interact with Ethereum, you need every operation you perform, except for reads, you're essentially modifying the state of the network, which means you have to pay for computation. That's not ideal for development. You can't pay money each time you just want to write a unit test. So what the Ethereum community has built, specifically under Truffle, is a tool called Ganache. So it's there's a UI, but to be honest, I prefer the CLI. So all you have to do is search for Ganache CLI. Right, this should take you to a few search results. Click on the one that says npm.js, and then again, just run this command. So once you install this globally, make sure you use -g, right? npm install -g Ganache-CLI. Once you do this, you should then be able to globally access Ganache. So let me just do Ganache-help. Oops, so it's a Ganache-CLI. Okay, and he gets all this information. Okay, so now that we have things set up, let's actually create a boilerplate code. So we're going to go to Truffle, and let's see, you go to boxes. Okay, these are just already created example code bases. I'm looking for something very basic that we can use for testing. Let's go to the documentation instead. Truffle, search for tests. Okay, so we're going to be writing tests in JavaScript. Okay, so here they're using the Metacoin Truffle Box. Okay, so we're going to open that. How do we install this? So the command is truffle on box Metacoin. Just highlight that, copy it, and paste it in a file location. I've created something called cold chain, and that is my working directory for VS Code. So we're just going to hit this command, truffle unbox Metacoin. And as you can see, what that does in here is it's unboxes, or in other words, downloads a boilerplate code, a boilerplate repository. And let's just go over that very quickly. So you have your truffle config.js file. This is your configuration to connect Truffle, your development tool for Ethereum or for smart contract development, to different networks. And we'll get to this very shortly. Then, of course, you have your license, open source, Git attributes, and all that. Then you have your contracts repository. So you can see there's some smart contracts in here, some library for conversion. You have a Metacoin, you have migrations. So the migrations contract essentially, just think of it as, for lack of better terms, sort of version control for your for your development purposes. Then you'd have a migrations folder, and in here you'd have a small script in JavaScript that gets the migrations artifacts, which we currently don't have any artifacts, but this artifact is a truffle. It's a truffle object that is injected in runtime. Essentially, what it does is it allows you to access smart contracts that have been compiled and also deployed to a blockchain or a blockchain simulation like Ganache using Truffle. Then you have another script to deploy a contract. Okay, and then finally you have your test folder. So you can write tests in JavaScript to interact with your smart contract, or you can create a test Solidity contract to interact with your original contract. Okay, so let's modify this a little bit. So in contracts, we're going to get rid of these two because we don't need them. It's trash. Make sure you keep migrations. So what we're going to do is we're going to create a cold chain. .sol. Okay, so let's go to Remix, copy our code, paste that here. Okay, now we can get rid of this. We'll just be writing a Solidity in JavaScript today. Okay, and instead of Metacoin, just rename this to cold chain.js. Migrations in here, you can just remove this. Let's find and replace with cold chain. Okay, and we don't need these. We do have a library contract, but it's fine because it's all in the same file. Okay, so now here's where things get interesting. So what you're just going to do is you can split your terminal. If you're not using VS Code, it's fine. You can just open a new terminal window or terminal tab. Essentially, what we want to do here is we want to run Ganache. So we're going to say Ganache-CLI, and we want to run it using something called a mnemonic. Okay, so anytime you're anytime you want to create a new wallet, if you've ever used an extension like MetaMask or anything, you notice you're provided with this seed phrase. So let's go over to, let's go back, let's search, let's find that, other Ganache. Okay, I don't know if they would have, okay, cool. So there is something here, but it's not exactly what we're looking for. So essentially what we're going to do now is, let me run this without the -m. So you see what's going to happen is and I'll collapse this. It's going to run, it's going to spit out this command, spit out this output. So what exactly are you looking at? You have 10 available accounts, each of which have 100 ETH. So this is not on the mainnet. Ganache is running an instance of the JavaScript implementation of the Ethereum virtual machine, right? So I actually have the EVM running on my laptop at this moment because of Ganache. So, and in other words, and I can access that through JSON RPC and some limited methods. So essentially, I'm running a lightweight version of Ethereum that is isolated from the real world on my laptop, so a single node. And for each of these accounts up here, you have the corresponding private key. Of course, this is just for development, right? You wouldn't actually use this out there. Now you see the mnemonic. The mnemonic is it's just what you use to generate. So this mnemonic is used to generate or to recover this. So if you're ever to lose your private keys, all you need to do is remember your mnemonic. And then you see some default configurations, and it tells you here it's a listing on localhost 85 ports 8545. So why is that important? So that is where the Ethereum node, right, Ganache, right, the test Ethereum node just for development is running. So we're going to go into our truffle config. Then we're going to comment on comment the networks object, right? And we can remove this. We don't need it. And all we have to, so we just leave development and we change this to 8545 because that's what Ganache has offered us. So 8545. So we're just going to save that. Okay. So right now what I've done is I've told Truffle that when it's running, it should connect to this instance of Ganache. Okay. So now the next thing to do is to then replace this with my own mnemonic. Why? If you remember from our smart contracts, at some point we're going to be playing around with signatures. So when you need to sign messages in Ethereum, you need a private key, right? So that's asymmetric cryptography. You sign the message with a private key, someone else verifies the message using your public key. So because we'll be signing messages, I'm going to need to access private keys. So what I would need to do is I'll need to start, essentially I'll need to restart Ganache using my own mnemonic, which will generate my set of private keys that I want. So here we say Ganache-CLI-M, then in double quotes. So I'm just going to fetch the mnemonic I use for development, which of course, these are not real, they're not real accounts or anything. So I'm just going to, okay, let me just, since you're listening, let me just copy, type it out rather than pasting. So candy, maple, cake, sugar, pudding, cream, honey, rich, smooth, crumble, sweet treat. Okay, did I type that out correctly? Oops. Yep, candy, maple cake, sugar, pudding, cream, honey, rich, smooth, crumble, sweet treats. Okay, now when I hit enter, you can see a new instance of Ganache has started up. And of course, this time the private keys are different. It's really hard to tell, but you can see down here in the mnemonic, you can see my seed phrase, right? So you might hear it referred to as a seed phrase, right? That's what is used to generate consistently the same private keys. I can keep restarting Ganache, and it's always going to be these 10 that load up. Okay, so now we have that running. Now we actually have to compile our smart contracts. Okay, so we compile this in the browser in Remix using the compiler. However, we need to compile that locally because when you compile the contract, you get a lot of data. So as you see here, the compilation details, you get a lot of data, right? The name, metadata, and so on. But what we mainly need is the metadata, sorry, the bytecode, as well as the ABI, right? We'll see. Actually, since we're using Truffle, we may not exactly get exposed to that, but I will show you in the artifacts. Okay, so what we're going to do is we're going to say Truffle. So now in this tab, so we can just minimize this a bit. Good to say over here, Truffle compile. Okay, so I'm going to run the compile command. This would look for the contracts folder and compile every smart contract in there. Okay, so it says this failed. All right. Okay, so when you get errors like this, don't panic, just see what it is. Source file requires different compiler version. Okay, all right, so that means truffle config. All right, we just need to tell Truffle what compiler version to use. All right, so the current compiler is 0516. Meanwhile, our smart contract is in this range. Okay, so we just have to tell Truffle what version we want. So in our Truffle compile, truffle-config, all right, okay, we can just delete all this because this is just noise. We don't need this at the moment. Yep, we don't need all this. Okay, cool. So here I can just say compilers, open a new object, and the Sol-C compiler. If you remember when we did Truffle version at the beginning, it told us the version of Solidity. So now I'm going to say version. Okay, let's try that first. Let's do Truffle version. Okay, so just as the last error message said, it's 0516. So Truffle version, and let's just copy what we have in here. Copy. Okay, so now let's run Truffle version again. Okay, cool. Now you see the version, we bumped up the compiler version. So Solidity.js is a different library that is used to compile Solidity smart contracts. Okay, cool. So now let's try Truffle compile again. Okay, so, all right. Yes, so I need to go clean that up. Okay, it's complaining visibility. Yeah, so contract is, sorry, constructor is already public. Okay. So sometimes, you know, with open source, you have to do some initial work. Okay, so it's compiled and there are just some warnings. It's fine. We're gonna have to look at that. But what's most important is now you see we have a new folder. Right, so we have a new folder called build. Okay, and now you see these. So build/contracts. So contracts is a subfolder under the build folder. Okay, so you can see our migrations JSON file. So this is the artifacts, right? So earlier you saw under this migrations, there was something called artifacts, okay? So artifacts that require, what that's doing is that Truffle, so subsequently, when we do Truffle deploy, Truffle migrates, Truffle test, other commands, Truffle is going to look into, it's going to try and set things up with the migrations, and then it's going to get these artifacts from this build/contracts folder. Okay, so when you say artifacts that require migrations, this is not your regular Node.js require function, right? This is artifacts that require, that is injected by Truffle, okay? And that gets resolved in here. So you can see it's a really huge object, right? So there's a contract name, there's the ABI of the contract, right? The application binary interface. You can see the bytecode, as I mentioned, which is important. And you can see a host of other pieces of information, right? Let's see what else we have at the bottom. Yeah, so you have all sorts of different things. It even tells you when it was updated, the time. Okay, so that's for migrations. We can see the CryptoSuite library. Okay, yeah, so you can see the CryptoSuite library, and we can see the cold chain contract that is represented as a JSON. So this essentially is what Truffle would use to build the instance of the contract in JavaScript, right? So our contract is in Solidity, but what Truffle does is that once you compile it, it uses all that information to create this object that can be used as an interface between your JavaScript code and operations on the blockchain. Okay, so now what we want to do is we want to go into our tests, right? We want to go into our tests file, okay? And we want to just close these. So the lots of, I don't like this. Okay, and we want to essentially start writing our tests to interact with the blockchain. Okay, so I could even just do truffle deploy just to demonstrate to you. You can see nothing has happened on the blockchain just yet. On our local blockchain, nothing has happened just yet. If I were to run truffle deploy, it's going to go to this script, and then it's going to say deployer, right, which is going to be passed to us, .deploy the cold chain artifact. So it gets the cold chain artifact, and then it runs deployer.deploy that cold chain artifact, right? Now let's do that. So we're going to say truffle deploy. Now watch what's going to happen on the blockchain side. So it's compiling the contracts once again, because every time you deploy to the blockchain, you have to make sure you have the latest version. And now you see all of a sudden, we have activity here on the blockchain, right? So what do we have here? Set truffle deploy. That's restarted the compiling, the compilation of the contracts, right? Then you can see here, there's the network name development, which is what is in our truffle config development. Okay, and you can see the initial migration file, right? The first JavaScript file in the migrations folder, right? So it deploys the migration smart contract, which is just, as I mentioned, it's not something we have to modify. It's something that Truffle has put in there to assist. And this is our actual smart contract, cold chain. Okay, so what do you see? There's a transaction hash. So when you deploy a smart contract, what happens is that you're also sending a transaction. Okay, so in Ethereum, there's a difference between externally owned accounts and smart contract accounts. Okay, let me see if I can find an image. Okay, so an externally owned account, right? That's your regular accounts that you use for, you know, sending cryptocurrency back and forth. Yep, open image in the tab. Okay, so on Ethereum, you have basically two types of accounts. There's the EOA account, and then there's the smart contract account. So essentially the difference is that the smart contract account also has code allocated to it. Just think of it as there's space on the blockchain that's created to store code for that account. So the code that's being stored there is the bytecode. right? That's why every time you compile your contract, or anytime you're trying to interact with the smart contract, make sure you're using the latest version of the code and you deploy that to the network using the correct bytecode. So what's happening is that when you're sending a transaction, right? So when you're sending a transaction and you include data or bytecode, that tells Ethereum that you're not just sending a regular transaction, you're sending a smart contract transaction. So it's still a transaction, so it creates a transaction hash. Then it gives you back the contract address, right? So now for me, this contract account, right, is this value, which is still an Ethereum address. Okay, and the account here is just this should be my, which account is this? Okay, I can't exactly see which one it is. Oh no, okay, yes. So this is where we started from with our mnemonic. So you can see this is my first account, right? 0x627, that's 0x627. So what Truffle is doing is that because all these test accounts have been assigned with 100 ETH each, right? I essentially can do as much testing as I want. And you can see the cost of deploying this contract, 0.04 ETH, approximately 0.05 ETH. That was used to deploy this contract. And now I have 99.95 ETH left. Okay. And I deployed 2 contracts, by the way. I deployed the migrations contract as well as the cold chain contract. Okay, so all these things you see here, these are messages, right? These are JSON RPC messages that are sent to this port. Okay, so Truffle is using a library within it called web3.js. That's why when we did Truffle version, right? We did Truffle version. What did you see? Let me see if I can find it again. Okay, so if I run Truffle version one more time, you see it's referencing web3.js, right? Web3.js, as I mentioned, allows you to interact with the blockchain, okay? So web3.js is inside of Truffle. Truffle is sending messages to web3.js, which then makes a call, right, over JSON RPC. So it's an HTTP call regular, and it's to this JSON RPC port. So Ethereum nodes by default, you'd usually see 8545. That's the JSON RPC port, right? So you can see the full, just go online. You can see the full spec. You just look for it, and you should find the latest spec online. You to see also the different messages. Okay, so this is different from REST API. This is not a REST API. This is a JSON RPC API port. Okay, and you're sending messages, right? So all of these messages, right? This reflects what web3.js is calling, and web3.js is calling these messages, right? Or you can think of them in a way, roughly think of them as endpoints. Not exactly, but these are procedures on the blockchain that are being remotely called as an RPC, right? And web3.js is doing that because that's what Truffle is telling it to do. Okay, so this is everything that is needed, right, for Truffle to deploy the transactions, right? So you can see there's a send transaction. Every time you see send transaction, you see there's this new, you see this thing here, right? That's the transaction. And you see there's some transactions that have contract created and others that don't, right? So you can see this contract address, that's this one, right? So you can see there are two different things. You can see there's also another contract created, 8CDAF, which is the migrations contract. Okay, so that's, we've learned some of the things there. Okay, so all this is good. Now let's get into actual testing. We've set up our environments and all that. Let's start actually testing our smart contract and interact with it locally. Okay, so once again, if you like this kind of content, please hit the like button, subscribe, press the bell icon to be notified, share with others, and if you have any questions, please paste them in the comment section. Okay, all right, so you can see all of this code here is still referencing Metacoin because I'm yet to clean it up. So what I'm just going to do is, and if you're familiar with JavaScript testing, you can see that this type of testing is from the Mocha Chai framework. And that's essentially this style. You describe something and then you write the expectations and assert expectations and assertions for the test. Okay, so what we're going to do is we need to import a few helper libraries. So let's clean up everything here first. Okay, so let's clean up these first ones, these last two. And because this is smaller, let's change this to cold chain once again. Okay, so let's replace this with a small c, right? Okay, so we're telling truffle test. The truffle test script is going to see this command. So what would it do? Artifacts that require results here is going to find the cold chain artifact, load it in memory, right? And then it's going to call cold chain.deployed. Deployed is a function. So this artifact actually becomes of something of type truffle contract. Truffle contract is a type that is a class that is exposed by truffle, right? So truffle contract.deployed will get you the latest deployed instance, right? How do you know the latest deployed instance? Right, let's see if we can find it. Right, so you go to networks, where you see the last, so this is the network ID, then you see the address. Okay, so that's how Truffle will get the latest. Okay, so Truffle itself has used this, file to essentially tell itself how to interact with the blockchain. So I see it's a very reasonable development tool. Okay, so now heading back to our test. So we don't have a function called get balance. All of these are just what was here before. So I'm just going to clean this up. So this would be some actual value. This is what we expect. And this would be our error message. This would be some error message, okay? So as I mentioned, we're going to have to install some extra libraries, okay? So we're going to install in development mode, right? So we need to first of all make this an npm project. This is not npm yet. So we're just going to say npm init-y. Okay, so that just creates a package JSON for us. And what we're going to do is to say, so the main file, there's actually no main file. And for testing, we're just going to replace this with truffle test. Okay, of course, you'd have to spin up Ganache. You know what, I should probably just copy that as well. Okay, and obviously I need to escape these. Okay, all right. So the libraries we're going to install are which? We're going to start with something called OpenZeppelin/test helpers. Okay, so we're just going to say npm install -d, right, in capital D. So that's to install under dev dependencies, and it's called open Zeppelin /test -helpers. Okay, there's some utils that we will need from that. Okay, so that's going to install. Okay, next is called, so we're just going to remove this @truffle /hd wallets -provider, because we will need the custom mnemonic to access our private keys. And I'm just going to install web3 for us. So yes, Truffle already provides web3, but we're just going to have to install it outside as a dev dependency for our project. Okay, perfect. And now you can see in our package.json, these three have now been installed. All right, so I'm just going to copy this one by one and right at the top. I'm going to say const. I'm going to do some object destructuring here. Big number, and I'll get to that soon. Equals require this open Zeppelin test helpers. Then we're going to install the HD wallet provider. So const HD wallets provider equals require that value. Then we're going to say const web3 notes capital web W in web3 equals require web3. Okay. All right. So we have these now. What we have to do is to figure out how to interact with our contracts. So the first thing in the flow, right, of our smart contracts is we want to start adding entities. We want to add people who will be in this contract. So the issuers, the verifier, the prover roles, modes. So people like the inspector, the manufacturer, and so on. Okay, so what we're going to do is we're going to start with that. Okay, so first of all, I'm going to create a before, and it's going to have an asynchronous function within it. So just as I mentioned, this is pretty much how things were in Mocha and Chai. Okay, so let's create something called this.cold chain instance. So we're going to need to access it in multiple places. So for now, in multiple test cases. So for now, just make this an empty object. Then we're going to say the owner or the deployer. It's owner equals accounts and 0. So where is accounts coming from? So you can see we have contracts here. Okay, so contract is again, this is going to be injected by Truffle during runtime. So what that does is that it takes in the name of essentially the contract we're testing, right? And then it provides you with a callback function. So this callback function passes in a single parameter, which is the list of accounts. As you guess, the accounts will be those that were created here. So these 10 accounts will now be accessible. So what I'm doing here when I say accounts of 0, right, I'm getting the first account, which is this one. If you remember, I hope I still have it. That was the account who deployed both the migrations contracts as well as the, do I still have it? As well as the cold chain contracts. Okay, so that's the first account in there. Okay, now we need to set up a bunch of things, right? So we have our vaccine objects or struct. We have, things like brand. We have entities that have different roles. We have or modes. Sorry, I keep saying roles. We have statuses and all that. So we need to set up all the default values. So we're going to say this dot vaccine brands. It's going to be a new object. In there, the first value brings down. So the first value is going to be Pfizer. Okay, just make this simple. Pfizer, and what's the official name? It's like Pfizer Bio and Tech. Okay, then we're going to have Moderna. I should do some Moderna. Okay, of course, I'm writing things this way because that's the cleaner way to write code. Then we're going to have the Janssen, which is actually Johnson and Johnson's. Yeah, it's an interesting name. And we're going to have the Sputnik, which you saw in the first video. Okay, Sputnik 5. Okay, so these are the default vaccine brands. Then we're going to have some enums. Okay, so enums. Now, the reason we need to configure these from outside is that enums are represented as numbers when you go between Solidity and JavaScript, right? Rather than, as these values, right? They're represented as numbers. So we need a way to properly handle that. So we're going to say this dot mode enums equals. So we're going to have our issuer. They would have value issuer. They would have the position 0. Right, so our issuer is the first one. So this was just change this to verifier. Position 1. Then we have the prover. Copy that. Paste it here. Position 3. Okay. Then we also have the status enums. So let's just. Ideally, these should be in one object, but I don't want to have us, have too many nested values. So what enums do we have here? Under status, we have all this. So let me put that here. Okay, so let's say manufactured. Yeah, this is it's kind of annoying. We have 2 delivering. Okay, so let's say delivering 1. It's going to be deliver international. Then we have stored, which comes after. Okay, then yeah, let's just have 2 more. Okay, we have delivering local. We can call this delivering 2. And finally, we have delivered. It should be 4. It should be 5. Okay, delivered. Okay. All right. So we have these enums. Then our default entities. Right. So the default entities. And who are they? So these are the system actors, as you remember in video 1. So we can say this, the default entities. It's going to be a new object. And we're going to have, so let's say there's a first manufacturer. Okay, that's a mistake. Let's say there's, let's say we have 2 manufacturers in our flow, right? So they would have, let's give them an ID. right? Because remember in our entities have an ID, which is actually an address. So where are we going to get that address from? We have the accounts. Remember, accounts reference this. So we've already used the first account. So we're going to move on to the next. Accounts, that's one. And what mode will they be? Will the manufacturer be in? So the manufacturer is going to have to prove, right? They'll have to prove their certificates. And the certificates will be issued to them by an inspector who will define, right? So they will always be in the mode of a prover, okay? And it's a prover of val, right? And then we're going to have another manufacturer. It's called the manufacturer B. Okay, we'll just change this. Then we're going to have an inspector. Okay, so the inspector is the next person. You get that the third account. They'll be an issuer, right? They would issue credentials to people. The inspector will show up at the manufacturing plant or facility and then perform the inspections, and if everything meets quality standards, then they would issue a certificate. Right, then we have a distributor. So distributor. So let's say we have so distributor A, right? Maybe the international distributor. Let's give them a better name. Distributor. Global. Probably should have even called this global. So international. Give them accounts for. So they will need to be a verifier, right? Because they need to, when they get there, they can't trust, as we said earlier when we were gathering the requirements of video one, they can't just trust the manufacturer. They have to verify that certificates. So the distributor will operate in this mode, right? So let's have a second one, will be local. So there's a global distributor who will move between countries. They'll move vaccine batches between countries. And there'll be the local one who, moves in between regions, between cities and all that. They would also be a verifier. Right. Then let's have an immunizer. So the immunizer would be, the doctor or, whoever is providing the patients or the travelers with a vaccine certificate. So here, let's say issuer. Okay, they would issue a certificate, right? And then we're going to have a traveler, right? The traveler needs to present their certificates, right? So they would actually be a prover, right? They need to prove they need to prove that they have the right certificates to enter the country. And who's the last person, right? Border agents. So we're going to give them account 8. And of course, as a guest, there'll be a verifier. Right? So just right click anywhere and hit format documents, or just to clean things up. Okay, we don't need all this anymore. Okay, then we also have another struct called the vaccine batches. Okay, so of course, we're not going to initialize it from the outside because this is only initialized from inside our Solidity code. And so from the outside, we're just going to create the vaccine batch. We'll just create some mock values. So all these values, right, we're just adding them because of tests. Right? In reality, you do things differently. We're adding them because we're testing. Okay, so we're going to say this dot default. So we can call them default. We can just say mock, stop data. Something just to use for testing. We can have as many vaccine batches as we want, right? Let's give it a key. So just because I can't think of any other name, we'll just use numbers. So the brand, we have our this dot vaccine brands dot let's say Pfizer. Okay, what's the value of that again? Yeah, the Pfizer. That'll give us a string. And then who's the manufacturer? So let's say the manufacturer of this vaccine batch. Let's give them, so this dot default entities. Let's say manufacturer A. That's manufacturer A. They're the one who manufactured this Pfizer vaccine. Let them just format documents as clean. Okay, then yeah, let's basically just let's do that a few more times. Okay, so how many vaccine brands do we have? 1, 2, 3, 4. Okay, let's say somewhere close to 10. All right, 2, 3, 4, 5, 6, 7, just so we can have it spread evenly. 8, 9. Okay, so we've already used Pfizer manufacturer A. Oops, so we won't just use A, we'd have to say .id. All right. Okay, no problem. So what I'm just doing is Alt down and sorry, Alt and then just click, or so hold Alt and just keep clicking, or if you're in a Mac, hold Option and just keep clicking. So we need to say .id, right? Why .id? Because you remember, .id is the actual account, right? And in the vaccine batch, the manufacturer is identified based on their accounts, based on their address. Okay, so let's change this. Let's randomize this. So we have Pfizer. Okay, let's do Moderna. Let's do Janssen. Okay, Sputnik. Okay, Pfizer. There's another Moderna. I think these are the most popular. Moderna again. This time Sputnik. This time Janssen. Okay, so how many Pfizer? 3. Moderna 3. Janssen. Oops. Janssen 2. Sputnik 2. Yeah, I think that's fine. I mean, Moderna and Pfizer seem to be the most popular. Okay, so AA, let's get this on B. Let's get this on B as well. Get this on B. Okay, and let's give this a B, give this another B. Okay, just to evenly spread it. So we have 2 manufacturers for 4 vaccines in our test. Okay, so remember earlier we had this cold chain instance. So actually let's cut that. So let's cut it. So Command X or Control X. Let's paste it down here. So this will be so as you can see here, there's await cold chain deploy. So we're going to cut that and paste that here. So where's cold chain coming from? Cold chain, command click this, is the artifact, okay? All right. And we're getting the most recent deployed instance. That will give us an instance of the smart contract that we can interact with. All right, that gives us an instance that we can interact with. So this is an instance of the truffle contract. So this is an instance of cold chain. Cold chain is of type truffle contract, right? And that truffle contract has a public method called deployed. Right, truffle contract is actually a JavaScript class, right? So just think of it as a JavaScript object or JavaScript class that allows you to interact with it, and behind the scenes, it actually interacts with the smart contracts. Right? We already explained with web3.js and all that. You saw all these methods down here. It's all these methods will be called, okay? And then we would also need, so let's say this, oops, because later on, we're going to do some things with signing. So say provider or URL should be fine. And we're just going to give the URL to our local blockchain. So, of course, 127, or you can just use localhost, same thing. Okay, so we've basically done the setup, right? So now let's try to actually add entities. Okay, we've done the setup. So let's add entities. Right, so you should add without error. Okay, so how do we do this? We want to send all of these entities to the blockchain, right? So all those entities in there, we want to pass them into this add entity function, right? That means we're going to need a for loop. We're going to do things in a loop, okay? So I'm going to say for host entity in this dot default entities. Okay, we're going to say let's destructure it and get the ID and the mode. Okay, and say this dot default entities at this entity, because just remember how our data structure is, right? It's an object that has these different entities, and we actually want these values. So ID and mode, which is this. Okay, and now what are we going to do? We actually need, oops, not this one. Let's bring this up. So we need to call a function. So the call chain instance, right? So this smart contract, we need to call a function. Which function? Add entity. So you just copy the function like that, and you say add entity. Okay, and what does it take? An address as the ID and a mode of type string. Okay. So what are we going to do? We're going to pass in, let's expand this. Let's hit this to a new line. The ID, which is this one. We're going to pass in the mode. And then we're going to do something that is specific to blockchain development. Okay, especially these kinds of blockchains like Ethereum. We're going to pass in an object that represents options. Okay, so that's basically Truffle. So Truffle is providing you with, all right, you have these methods on your smart contract. You can pass in your parameters. You can also pass in some optional values. You can also pass in optional values that can be used to configure or modify the way you're calling the function. Okay, so we're going to say from, we're creating an object, and we're saying from to this dot owner, right? This dot owner, do you remember the first account? So we're using that first account as the account to interact with the blockchain, or to add these entities. Okay, so what does that do? We're sending, when we interact with the smart contract, we're sending a transaction, right? And transactions, everything on the blockchain is, the blockchain doesn't initiate operations. It's entities from the outside that have to trigger an operation on the blockchain. Like they have to do something to the blockchain before it does anything. So we have to tell it who is the person sending it. And they will be the ones to actually pay for this transaction. So that's from this the owner. So this the owner will be the one to pay. Okay, so we're not getting back a balance, right? When we add an entity, we get back, we're just going to get back some, I think it should be the transaction hash or something. So we're going to say roll, results. I don't know why I keep saying roll. We're going to say results, okay? And now, how do we verify that what we've done is correct? Okay, we need a way to verify that what we've done is correct. So we're emitting an event. So can we check that what is emitted in the event is indeed what we've passed? Yes, this is why we imported this from this helper library. So we're going to copy that expected event. Okay, and we're going to go here, paste it, and it's a function. So we're going to pass in result.receipt. Okay, so you'd see what receipt is. Right, so this results object will contain lots of different things that describe the transaction. So we're going to take the receipt key in that object. Okay, and the name of our event is add entity. So we're going to pass that in. And finally, we need to send in the data we're expecting. Okay, so there's going to be an entity ID. We expect that that entity ID will be this ID that we extracted from this specific entity. Okay, and we have something else as well. We have an entity mode. And then as you guessed, this will be this value. All right, so that's that. So let's move this assertion inside our for loop. All right. So I'm going to just comment this out. Let's see what our code is like so far. We've been writing code all this while. Let's see what it's like. So we'll run it once, because this is a for loop and we have 10 items. We'll run it once, and let me console.log the results we receive from the blockchain. So we receive this from the blockchain, just console.log. So now we're going to say truffle test. Okay, so we've done truffle compile, truffle deploy. Now we're saying truffle test. Okay, so it's compiling the contracts again. Make it, that's to ensure that it has the latest. And now we have an error. Expected a function. Okay, at before. Expected a function at before. Let's see. Expected a function at before. Maybe I didn't close the brackets. Line 10. Expected a function. Expected a function. Did I close something properly? Type error expected a function. Where is this exactly? Type error expected function. It's expected function. Okay, let me just reduce this slowly. So we have this. We have mode enums, status enums, default entities. Okay, something didn't close well. Yeah, something didn't close well. Okay, so nothing here. Wait, this should be true. Okay. It's kind of strange. Status enums. Okay, default entities. What did I not close properly? Default vaccine batches. So why does it say it's expected a function? Okay, let's reduce the code a little bit. If you can see the error, just paste it. Maybe you can find it before I do. So cold chain, line 10. Line 10 at 3. No, low dash. Where did this come from? Low dash. Okay, yeah, so there was some weird imports. Okay, this is the issue sometimes with running things in an IDE. Don't know who asked it to import low dash. Precious time. Okay, all right, so hit truffle test. Now it's compiling. Okay, so it says cold chain instance is not defined because I need to say this dot cold chain instance. Okay, because that's this value. All right, so let's save that. Run it again. Truffle test. Okay, good. So now we have one test passing, one test failing. Okay, so what does this say? Should add entities. Why did this fail? So we console log the results, right? So this is what the results comes out as, right? So it has a transaction. This is a transaction hash. You can see it here as well. It has a receipt object. Receipt contains transaction hash, transaction index. So that's the first transaction in the block. This is the block hash. This is block number 25. If we go all the way down here, see block number 25, that's this one. You can see the transaction hash 0x24e, 0x24e. Right, then you can see there's some logs. Right, the logs are due to the events that we emitted. Okay, they're due to the events that we emitted from the smart contract. Okay, so you can see the log. Right, we have add entity. Right, and the values are actually they should be in here. Okay, now the expected events is cold chain dot add entity. So this is what actually came from the blockchain. So entity ID is this 0x F17, and then entity mode is prover. So I'm wondering why. Is there anything else? Mode, default entities. Is there anything I'm missing? Expected event is not a function. Expected event is not a function. That is, oh, sorry, it's expect event, not expected event. If I run that again. So one thing that is annoying is that it keeps recompiling the contract. So I'm going to use the latest. Okay, so now you can see everything worked. So I don't need this console log. That was just for demonstration. So if I just run truffle tests on its own, you can see it works. Okay, so over here, it's running very quickly because I added a break keyword. Right, so I just wanted it to work just for the first one as a demonstration. Okay, but this isn't enough, right? We have some other ways of checking if it's indeed added, because you can see we're adding things to the entities uh, uh, map over here, right? So is it possible for us to do? Yes, because of the public keyword. When you use the public keyword in Solidity for instance variables or state variables, right, things that are up here on the states of the contract, Solidity, the API creates an automatic getter function for you. So I don't need to declare a new function called get entities. All I need to just say is entities and call it public if I want to be able to access this. So I'll just be able to pass in the address and get the corresponding entity. So to do that, I'm going to say const entity. Well, I already have something, so let's call it retrieved entity equals await because it's an asynchronous operation, right? And we can write await because of the async keyword. I'm assuming you should be familiar with some of that in JavaScript. So it's asynchronous because we're calling the blockchain and we have to wait. And it's an operation that could take some time. So we need to make it asynchronous. So here, the await keyword allows us to wait for that operation. Well, when I say wait, I mean our code is going to look synchronous, but the await keyword is actually telling the Node.js what's it called? Is it the event queue to essentially return us this value once it has resolved. So we're going to say code chain instance, right? And we're going to say dot entities. So you see here, we called add entity. We don't have a function called entities, but we have this value and it's public. So that's why we can access it. And because we're just doing a read, we're not mutating the state of the network. We must use, we're going to use the call. Okay, so we're going to say dot call. I'm going to pass in the ID. And this time around, we don't need to pass in anybody's from address. Right, so we're just passing the ID that we're interested in. This will give us back the corresponding entity in the map, the Solidity. Okay, now we're going to use this value. So the actual, so I actually swapped the positions of these. So usually what would happen is that the value you expect should be the one at the front, I think. So we're going to say we're expecting ID, okay? But what actually came back is retrieved entity dot ID, right? Where does the ID come from? Is of type entity. Entity has an ID, and this is of type address. ID here, right, is of type address as well, okay? So we're just going to put that in here, and if it doesn't work, we're going to say mismatched IDs. Apart from IDs, we also have the modes, right? So for the mode, it's going to come back. Remember I said enums would, they get weirdly changed into a number. So we're going to say this dot mode enums at this specific mode, and we're going to get its position. Right, so this mode, we're going to get its position, which would be a 0. Okay, so we're just going to go back to our code here, and we're going to say retrieved entity dot mode. I'm going to have to turn it into a string because it's going to be of type big number. It's going to be of type big number because the numbers, there's an issue with numbers when you're dealing with Solidity where remember the data type we're using is uint or uint256, right? So that's a large number that JavaScript isn't able to represent. So there's this new data type or a class called bn, which represents big number. So it's an easier way to interact with numbers, large numbers between JavaScript and Solidity. Okay, so we're going to say truffle tests. And let's see what this does. So again, it's going to recompile the contracts. And okay, expected 2 to equal 1. All right, that's interesting. Expected 2 to equal 1. Expected 2 to equal 1. Should add entity successfully. Mismatched modes. Okay, mismatched modes. So who did we add first? The first person we added in here is the prover. The prover is mode 2. That's where it's position 2, right? Okay, yeah, so it's just because in here, prover is actually in a different position than we actually have them. So let's reorder it. So let's move the prover up, make them position 1, just to keep things simple. No need to rewrite the smart contract. So we can say truffle tests. Okay, and by the way, for it to have gotten here, it means that this already worked and passed. Okay, you can see it works. Okay, so the values are accurate. So we're able to add the values into the entities into the smart contract on the blockchain, and we're able to check. Right, so we're able to check the entities map to see that indeed they were added there. Okay, next thing is to now add the vaccine batches. So we're essentially going to do something very similar. We're going to do something very similar. Let me copy this and change this to vaccine batches. Okay, but vaccine batches are a different kind of object. So what we're going to do is we're actually going to iterate this differently. I'm going to iterate this differently. So we're going to do the old style. So let's I equal 0, I is less than let's say object or keys. Right, so we want to get the length. Keys of this dot length, right? That gives us how large, how many vaccine batches we have. And then we're just going to do I++. All right. So now let's actually extract the vaccine batch. So it's going to be vaccine batches at I, so our current iteration. And we can do at I because we just gave them numbers as the keys. And what do we have in there? We have a brand and a manufacturer. Okay. Now we need to actually send an operation to the network. So previously we had add entity. So now we have add vaccine batch. Copy that and just paste that here. Okay, but instead of ID and mode, we have brand and manufacturer. So just like before, let's paste that there, and it's again be from this the owner. So we're going to verify that we emitted the event because we're also emitting an event. The name is add vaccine batch. Let's change that here, and you get the results. And then we should also get the keys, or I guess the names of the values in there. So it's a vaccine batch ID, as well as the manufacturer of this vaccine. So the batch ID, because this is the first, let's just say string of the current iteration. All right, and then we're just going to say this is the manufacturer. Then after doing that, we also just want to verify. So I don't need this. It's good to get rid of dead code. Then what we're going to do is make sure we're reading from the vaccine batches mapping. So copy that, put that in there. And we should receive a vaccine batch. All right, so oops. So we don't worry about these. I think that we get the points. Okay, so receive vaccine batch. It's going to be, what does a vaccine batch have? ID, brand, manufacturer, certificate IDs. Okay, so we don't have certificates yet, so that's fine. So we're going to say receive batch, vaccine batch, yeah, the brand. Manufacturer. And for now, this will be undefined because we're not expecting it to have any certificate IDs. Okay, so we're going to run this truffle test. Okay, it says ID is not defined. ID is not defined. Sorry, I, not ID. So the current declaration. So you can see there's a lot of transactions because now we're sending a lot of things. Or we're sending 10 entities, or is it 8 entities, and we're sending 10 vaccine batches. So 17 transactions. We just saw 17 transactions gone through, right? And for each of that, we have two test cases, right? So we have it should add entity successfully, which we see works, and it should add vaccine batches successfully, which we see works as well. So now let's actually issue a certificate. So we've set up our contract. Our contract knows about the different system actors that we call entities. It also now knows about all the different vaccine batches. So let's say we're now at the point where an inspector needs to go to a facility, or they need to go to a manufacturing plant to check for the to do some inspections, right, for quality control. So we're going to copy this, paste it. All right, so let's say issue a certificate. So this is our function is, you can see the function is, the issue certificate function is actually generic, right? It's generic enough. That's why we use these enums. So you can easily work on any issue and any program. So it doesn't matter if the scenario is immunizer to the patient or the traveler, or it's an inspector to manufacturer, it still works. So it should issue a certificate. Well, more accurately, what we want to do is to sign. So it should sign a message. So the message is going to represent a certificate. And store as is. So from the issuer to the approver. Right, that's what we're trying to accomplish here. Okay, so I'm going to go back and get my mnemonic. Right now, we're going to have to use the Web3 library directly. So I'm going to get my mnemonic. Let's delete all this. We don't need this for loop anymore. So I'm going to say const mnemonic is going to be equal to this phrase. All right. And let's move this down here because this isn't being used anywhere else. Okay. So what we're going to do here is create something called a provider object. So the way the web3.js library works is that you can instantiate it with, think of it as a provider for the wallet or a connection to the blockchain, right? So you can tell it what it should use to connect to the blockchain. So here, we're going to use the HD wallet provider, which you see I imported up here. We imported from Truffle. So we're going to simulate having a hardware wallet. I don't have anything connected to my laptop. I'm just using this hardware wallet class. Okay, so I can actually pass in, private keys or whatever. However, what I'm going to pass in instead is the mnemonic. Right, I'm going to pass in the mnemonic. Of course, you shouldn't just hard code these values here because we're testing, it's fine. So pass in the mnemonic and then the provider or URL. Just pass that in there. So we're going to take that provider and we're going to create, let's make this in this.web3 so we can access it later on. This.web3 is going to be new web3 with this provider. So this would be the provider engine inside of Web3. Okay, so where's this Web3 coming from? Up here. Okay, so we imported the web3.js library. We put it in here. And now we're creating an instance that we can access around our application, around this test file. Okay, so we've just set up another connection to the blockchain. And the reason is I would like to sign with my private key. There are other ways to do this, but this is just, this is one way to do this, just to get you familiar with different kinds of testing, different kinds of tools. So let's get some entities and let's actually do something. So we have our, who do we have? We have an inspector and we have manufacturer A. And where do we get them from? We're going to get them from this, the default entities. Okay, so I have them. The inspector will play the issuer role. They'll issue a certificate. They'll sign an issuer certificate to the manufacturer. Okay, so now what I'm going to say is const vaccine batch ID equals 0. It's okay to hard code this. I mean, we have many vaccine batches. We're just going to use the first one for demonstration purposes. So let's create a message that we're going to sign. So this message, this is just going to represent, for the purpose of testing, what an actual certificate would look like that will be signed by the inspector. So let's use template literals to make things easy. So you can say inspector, and in brackets, who would they be? We'll use $inspector.id, so that'll put the address. So inspector, this has, we should say certifies vaccine batch number, vaccine batch ID for manufacturer.id. Okay, so that is the message we're signing. So inspector certifies vaccine, I should just say has, oops, should say has certified vaccine batch number 0 for manufacturer this value, okay? Oops, about manufacturer A, right? Which is this value. So we're going to take that message and now we're going to sign it. So remember I said in order to sign, you need a private key, okay? So that's why I initialized Web3 with the hardware wallet provider using the mnemonic, which is the seed phrase. So I'm going to sign now. I'm just going to reference the account and to look up the private key. If I do not have the private key, it will actually fail. So we're going to say const signature equals awaits list of web3 dot f dot sign. Okay. So what are we going to put in there? There'll be two things, right? The message and then the inspector ID. So this is the person that's going to sign it, right? The inspector ID is the one who's going to sign this message. But we can't send it the message just as a string. We have to send it properly, right? We're going to issue the certificates. Okay, so what we're going to do is we're going to say this dot web3 dot utils dot kekak 256. Remember that's from the smart contracts that we wrote earlier. Okay, so this is the value of our signature, right? This is our signature. So we signed this message. So inspector has signed this message, and web3.f the sign would work because this instance of web3 knows about this inspector. So Ganache, I initiated Ganache with this mnemonic. I've initiated web3 with this mnemonic as well. Right, this is another way to prove that I'm the one who owns the private key. I have this mnemonic. Okay. Of course, please don't copy this mnemonic and try to use it in real life. This is something anybody can easily just copy. This is a public video. Okay. So we need to send this signature to the network, right? To a smart contract. That's where everything is going to be stored. Okay. So let's say const results is equal to await this dot cochain instance dot, what's the function name? Function is issue certificate. Takes an issuer approver status, takes in batch ID signature. Okay, I'm going to put that here. Of course, we know at the end we're going to have our from this the owner. Let's slow that down. Let's start putting in values. So I'm going to have our inspector, that's ID, right? Issuer, approver, status. I'm going to have manufacturer A, that's ID. Then for status, we're going to say this dot status enums dot manufacturer. Oops, what do I have here? Oh, manufactured, sorry, as a status, not the role or mode. Status is manufactured dot val. Okay, and what comes after the vaccine batch and the signature? Vaccine batch ID, vaccine batch ID, and our signature. Okay, so let's recap this slowly. Okay, so in this third scenario, or this third contract interaction or flow, what we're doing is we're signing. So this is happening off chain. This is off chain. We're signing off chain. Right. So I just call this within my JavaScript file. So I'm producing the signature here, and I'm sending the signature to my smart contract. Right. When my smart contract gets this signature, right, it's going to create a new certificate, right, using that signature that it just received, and it's going to push, it's going to add this certificate, this new certificate, into the global list of certificates, and to issue, it will emit an event. right? Which we can check, right? Which we're going to check now. So we're going to say expect event. So result plus receipts, issue certificates. And we're going to have the issuer is inspector.id, approver. Right? That's what it's called. Issuer, approver, certificate ID. And the approver is manufacturer. That's the person who now has to prove this later on when the distributor comes to pick it up. Right? And then we have the certificate ID. We're going to pass this in as a big number. So we're just going to create a big number instance of 0. And so where's big number coming from? Up here, from the test helpers. Okay, so we have this. So let's run it and see. Let's see if it works. It's doing the whole thing all over. Running. Okay, first tests, second test, and third tests failed. All right, so what did I do? It says prover, expected arguments prover to have value object, but got address. Okay, because I didn't add .id here. Okay. Error messages are good. Don't panic when you see the error messages. Read it, and in time, like you get familiar with them, right? You understand what the error message is telling you. Perfect. So what this is telling us is that yes, this issue certificates function on the blockchain ran successfully without errors and emitted an event. But since we're adding it into the certificates map, right, so we're adding it into the certificates map, let's do what we've done elsewhere and check that the certificate indeed was added. So we're going to say const retrieved certificate. I wonder, these are long variable names, but I like to make things descriptive, I'm trying to, there's no point being clever if nobody understands what you're trying to do. Right? Be clear, not clever, inform, don't impress. Okay, so we're going to call the certificates as the mapping, and we're just going to call, right, we're just going to get the first one. And the first one, that's the one we're dealing with here, the first certificates. Because this is the very first time we're issuing a certificate. So we're just going to get the first one. And when we get it, let's assert equal retrieve certificates .id 0. What does this certificate have again? ID, issuer, approver, signature, status. Okay. ID, issuer, approver, signature, status. Okay, so now ID and issuer. So this issuer is actually going to come back as an array. Or no, yeah, it's going to, is it going to come back as an object, sorry. So .id. So the issuer is who? Inspector. Then we're going to have our approver of ID. And who's that? The manufacturer A. And we're going to have our signature. The signature is going to be the one we just created, right? We want to be sure it's the right one. And then the status. Status is going to be this dot status enums dot manufacturer. We want to get the position, right? And just convert it to string. Okay. And again. Okay, what did I do wrong? Assert the equal is not a function. Assert the equal is not a function. This is yellow. Don't tell me something was imported. Yeah. Sometimes these things, you know. Okay, it's running again. First test, second test, third test. Perfect. So we've confirmed that it's also added in the certificates mapping. All right, so now we've signed. Okay, so what have we done? We've added entities. We've added vaccine patches. We signed the certificates on the client side, sent it to the blockchain, and issued the certificates. Now we need to finally check the certificate, or sorry, check the signature. So now imagine you're the distributor, you're a verifier. Now what you need to do is you need to check that the signature, the person who signed the certificate, right, the inspector, you need to check that the person who signed it on sent it to the blockchain is the same person you know and trust is the inspector, so that nobody falsified the message. Okay, so what we're going to do here is let's copy this, and this time we're going to say it should verify that the certificate's signature matches the issuer. Okay, so we don't need all the stuff. We will need, we're going to need this and this as well. We're not signing anymore. We've already signed before. And what we're going to do is let's get this. Okay, there isn't going to be another one, another event. So we're just going to get the certificates. Let's get the certificates. Let's just make this something simpler. And what we need to call this time around. Okay, let's just reduce all this. Okay, so what we need to call is the is matching signature. What does it take? A message ID, which I should have called certificate ID, and for cleaner code, and the issuer. Okay, so what's that? I'm gonna call this is matching signature. So that takes in, already forgot the message. So this is the exact same message as the one we signed, just copied and pasted, no modification. So the message, certificates.id that we just got, inspector.id, and from this owner. Okay, so in order to properly send the right thing, we'll say this.web3.utils.kcac, once again 256 of message. All right, so once this, what we get back is a Boolean. Okay, so what this is going to do is going to take the message, it's going to go into our crypto suite, right? So this is the certificate ID, and to extract the certificates from the blockchain, it will get that signature, okay, and the message. So the signature and the message will be used to recover the original signer. So if you go into this recover signer function, what are we doing? Like, this is why we made that change earlier. We have a message and a signature. So first we split the signature, right? to get out the right attributes. Then we create a prefix. We create a prefix hash. So we just add the message at the end of this prefix, right? So right here. And then it's this prefix hash that we put in here. So we return back the value of EC recover. EC recover returns an address. It tells you, okay, who was the original signer, right? And now when we get back the signer from this recover, right? This is the recovered signer. We're going to say return whether the recovered signer is equal to the issuer, right, of this certificate, right? So is the person who issued the certificate the same as the one the signature received? Okay, so that's essentially what we want to do. So here we're going to say does cert match. So let's just let's just say signature matches. Okay, I'm gonna put that here, and we expect it to be true. So we expect the signature to match. But is it really the signature that we're checking? Signer, right? It's the signer that we're concerned about. We want to be sure that it's the same person who signed, right? So the distributor knows about the inspector, and the distributor wants to be sure that when the manufacturer says, hey, this is my certificate from the blockchain, and this is the signature inside, the distributor should not trust the manufacturer. The distributor should verify the signature, extract the signer from it, and check whether the signer of that signature is equal to the inspector. Okay, so now let's send this. Let's see what we get. Perfect. So we successfully verified this functionality. That actually brings us to the end of this tutorial, but I'll go through it once more. So we don't have to go through the entire flow, from all the statuses, right? We've just proven that, okay, you can sign and issue certificates afterwards, someone else can independently verify that certificate. And as you remember, that happens at different points, right? That happens between the manufacturer, inspector, and distributor. It also happens between the immunizer, the traveler, and the border agent. The immunizer issues a certificate to the traveler. The traveler proves and presents the certificate to the border agent. The border agent does not trust the traveler. They have to verify the signature that in the certificate the traveler has presented to them. So we created, functions that are modular and could be reused for different flows in this system. Okay, so all of this code we can make this available. If you would like to have access to this code, please comment down below. Once again, please make sure to like this video, subscribe, and join us on our Discord server, which you can find on web3coders.com. Scroll down, join us on Discord, follow us on Twitter, follow our LinkedIn page, and of course, add your email in here so that you get notified for other things in the future. And we may publish this code to GitHub. So thank you, everyone. And I hope this was very useful to you. Have a nice day. Bye.